Hello everyone, welcome to my channel. So today I thought to discuss two very simple problems of that came in the Gate 2024 examination for the statistics paper. So let's first discuss this problem. It's a very simple problem of moment generating functions, right? So what they're saying? They're saying x is a random variable taking only two values, right? So x is a binary type of random variable taking only two values. X takes values 1 and 2. Now we are given with the expectation of x. What is the expectation of x? Expectation of x, we know by definition, is summation over small x times probability of capital X is equal to small x. So we know this small x is nothing but 1 and 2 because these are the only values that are taken by this random variable. So, and we can assign probability p to the value 1, and we can assign probability 1 minus p to the value 2. So by definition of expectation, we are getting it as p plus 2 into 1 minus p. Now we know that this value is 10 by 7, and if we get it correct, then p is 4 by 7, right? Now we have to obtain the fourth derivative of the moment generating function evaluated at 0. And what is the moment generating function? The moment generating function of x is by definition expectation of e to the power tx. So which is nothing but summation of x, summation over x e to the power tx times probability of capital X is equal to small x. So again you can get it as t p plus 2t into 1 minus p, right? So we have got this. We know theoretically that the first derivative of the moment generating function, that is mx prime t evaluated at t is equal to 0, is nothing but the expectation of x, which is 10 by 7 already given, right? So this is interesting. And mx prime of t is e to the power t p plus 2 into to the power 2t into 1 minus p, right? So if we again take a derivative, that is the second order derivative of the moment generating function, will be like this. So there is a pattern, right? With taking the second order derivative, then it's becoming 2 square. Then with the same pattern for the fourth order derivative, we'll be getting it as 2 to the power 4 e to the power 2t 1 minus p, right? Now they're asking the fourth order derivative evaluated at t is equal to 0. So we'll make it t is equal to 0. Then what we're getting, we replace the value of p, we'll be getting 52/7. This is the answer, and I think the option A is correct. Let's move on to the second problem. So here they're saying two fair dice, one having red and another having blue color, are tossed independently once. Let A be the event that the die having red color will show 5 or 6, and B be the event the sum of the outcomes will be 7, right? So we have two dice, red and blue, and they are tossed independently. So now they have declared some events. A is the event that the red colored die will show 5 or 6, right? So what is the probability of A? It will show either 5 or 6. Obviously 2/6, right? Because the event A has two favorable outcomes, 5 or 6. Both are favorable outcome for the event A. So the probability of A, by definition of probability, we're getting it as 2/6, the number of favorable outcomes divided by the total number of outcomes. Now we have to get the probability for the events B and C also. Okay, so before that, what we are aiming to, we are aiming to determine whether A and B are independent or not, whether A and C are independent or not. So if we can check that probability of B given A is equal to probability of B, if it happens, or probability of C given A is equal to probability of C, if it happens, if this happen, right, then it means that B is independent of A. It means A and C are independent, meaning, right? So if this happen, that there is no meaning of this conditioning. So what is the event B is saying? Event B is saying that sum of the outcomes will be 7. So two dices, right, they were tossed independently. So total number of outcomes is 36. Now the favorable outcomes for the event B will be this, right? 1 6, sum is 7. The red color die is showing 1 and the blue color die is showing 6, then sum is becoming 7. Similarly 6 1, right, 2 5, 5 2, 3 4, 4 3. So how many outcomes we're getting? There are 6 outcomes. So there are 6 favorable outcomes to this event B. So probability of B will be 6 by 36, which is 1 by 6. What will be the probability of C? Probability of C will be, we can derive the probability of C in similar fashion, because C, where, what is this event C? C is saying that sum of the outcomes will be 8. So what are the favorable outcomes here? 2 6, the red color showing 2, the blue color showing 6 number, the sum becomes 8. So 2 6 is a favorable outcome, 3 5 is a favorable outcome, and the opposites 6 2 and 5 3, right? So there are 4 favorable outcomes for the event C. So probability of C becoming 4 by 36, which is 1 by 9. Let me remove all these things. So we have got probability of A as 1 by 3, probability of B as 1 by 6, and probability of C as 1 by 9. Then probability of B given A, we are taking this event B given A because it makes more sense, right? Rather taking A given B, we are taking this B given A because the event A is that the red color die will show 5 or 6. So given, it means that given that the red color die has shown 5 or 6, what is the probability that the sum of the numbers shown by these two dices will be 7? Sum will be 7. So given that we know that the red color die has shown 5 or 6, what is the probability the sum will be 7? So that is what this probability essentially means, probability of B given A. So by definition of this conditional probability, we know that probability of B given A is nothing but B intersection A by probability of A, right? So for now we have to find the favorable events for the event B intersection A. B intersection A meaning, right, these two events are happening together. The red color die is showing 5 or 6 and sum will be 7. So the events are, the outcomes are 5 comma 2 or 6 comma 1. So these are the favorable outcomes for this event B intersection A, right? So only 2 outcomes are there which are favorable to B intersection A. So what will be the probability? It's 2 by 36, and probability of A we know, which is 1 by 3. Then probability of B given A is coming as 1 by 6. So what are we getting? We're getting probability of B given A 1 by 6 is equal to probability of B, which is 1 by 6. It essentially means that B and A are independent. Similarly, what will be the probability of C given A? So it means probability of C intersection A by probability of A. So what does this probability essentially mean? Given that the red colored die has shown 5 or 6, what is the probability that the sum will be 8? Sum of the numbers will be 8. So the favorable events for C intersection A is 3, 5, 5, 3, 6, 2. Sorry, my apologies. It will be 5, 3 and 6, 2, right? Because these numbers are fixed for the event A. So we have only two favorable outcomes, making it 2 by 36 divided by 1 by 3, making it to 1 by 6 again. But here probability of C is not 1 by 6, it's 1 by 9. So probability C given A is not is equal to probability of C. So what we're getting, A and B are independent, but A and C are not independent. So this option is correct option. Thank you for watching this video.